So remember that the goal is to make the base the same. So if I look at my bases, this is 4 to the power of 2 times x minus 4 equal to 8 to the power of 3x minus 2. My whole power here, this is a power. These are not like, they're together. You can't split them. All right, so my base here is 4 and my base here is 8. What would be my common base if I want to use a common base? 2. 2 to the power of what gives me 4? 2 to the power of 2. So I can change that 4 to 2 to the power of 2, right? And then I have the 2x minus 4. It's already there, okay? So all what I've done so far is I changed the 4, I changed this 4 to 2 to the power of 2. That's all what I've done so far. Now, how about that 8? 2 to the power of what gives me 8? 2 to the what gives me 8? 3. Right? And then you have 3x minus 2. Okay? So what I did is I changed that 8 to 2 to the power of 3. Now, you see that I have exponent to the exponent, exponent to the exponent. What does exponent law says? You multiply them, right? So that means I have to multiply that 2 with a 2 times x minus 4. So basically that's the same thing as writing 2 to the power of 4x minus 4, right? Because 2 times 2 gives me 4. And that is going to be 2 to the power of 3 times 3x minus 2. Because I'm multiplying power to the power. Why are you guys looking at me like this? We're going to turn it to a different number. We haven't multiplied yet.
What did you do with the first 2 to the power of 3?
This one?
Yeah.
You see that 3?
Yeah.
You see that 3 right here? Now it's right here. So that's 3 times the whole thing, times 3x minus 2. You didn't see the bracket. Now, do you see the product? Do you see the bracket?
Yeah.
Okay.
Yeah, I see the bracket. I just why wasn't it multiplied by?
We're going to multiply it now. This bracket means multiplication, right? Okay, so let's multiply that. What would this be? 4x minus 16. Because 4 times x is 4x. 4 times negative 4 is negative 16. Yes? And this is going to be what? Nine x minus 6. Are you happy now? Are they multiplied? I just wrote an extra step. Now I have the same base. I can drop the base and then keep my exponent, right? So that's going to be 4x minus 16 equals 9x minus 6. My 2 steps, I'm going to do them in one. I'm going to bring the x's to one side and the numbers to the other side. Doesn't matter which side you pick, right? So I'm going to bring the x's to this side, and I'm going to bring the numbers to the other side. So it's going to be 4x minus 9x equal to negative 6 plus 16. So it's going to be negative 5x equals to 10. And then divide by negative 5, so x equals negative 2. You can check your work by plugging in negative 2 for each x and then see if that's going to give you the same answer. Are we okay with that? Okay. So I'm just going to write it for the previous one. So in this case, I only had to change one of the bases, right? So I'm going to change the 27 into a 3. So this side is not going to change. This side is going to be, instead of 27, it's going to be 3 to the power of 3 to the power of x. Exponent law says power to the power, you multiply. Yes? So that's the same thing as writing 3 to the power of 5x plus 8 equals to 3 to the power of 3x. Because I have the same base, I can make my exponents equal. Bring the 5x over, so that's going to be negative 2x. And divide by negative 2. So my answer is going to be negative 4. Are we okay with that? All right. So what I want you guys to do later when I finish this lesson, I want you to try h by yourself, right? Understand it. Try it again. Here's a word problem. So a cross-country skier forgets a mug of coffee and a muffin in a snowbank. Their temperatures in degrees Celsius after t minutes can be modeled by the formulas T for coffee equals to, so T, the big T is temperature, is equal to 81 times 3 to the power of negative 2T. And the temperature for muffin equals to 27 times 3 to the power of negative 1. Determine when the coffee cools to the same temperature as the muffin. So what's the question asking me for? I'm looking for the time. When what? So when the T for the coffee is equal to T for the muffin? You guys agree with that? Okay, so I'm looking for the time, small t, when the T for the coffee is equal for the T of the muffin. Okay, what's the T coffee? What's the equation for that? T coffee equals to what? 1 times 3 to the power of negative 2t. T muffin is?
27 times 3 to the power of negative 1.
How would you solve for that T?
Do you get the same basis?
So you want to get the same basis? Do you guys agree with that?
Yeah.
So can I have, what would I change to a base of what? So,
We'll change 81 to the base of 3
okay,
and 27 to the base of 3.
good. So 81 to the base of 3, so that's 3 to the power of 4. Yeah? Okay, so I'm changing 81 to 3 to the power of 4, and then times 3 to the power of negative 2t. Yes?
Yeah.
Okay, and then change the 27 to 3 to the power of 3 times 3 to the power of negative 1. Now what do you want to do?
We'll add the powers.
Add the exponent? Why do we add the exponent?
Multiplication.
I'm multiplying with the same base. That's one of your exponent law, the multiplication law, right? When you're multiplying with the same base, you keep the base, you add the exponent. Do we remember that? Okay, so I'm going to keep my base, which is 3, and then I'm going to add 4 plus negative 2t, so that's 4 minus 2t. Are you guys okay with that? Equals to, what's 3 plus minus 1? 3 minus 1, which is 2. Okay? So you see that I keep the base the same. The base doesn't change. Okay? That being said, I have the same base on each side, and I have an equal sign. What does that mean? Drop the base, so that means 4 minus 2t equals to 2. Bring the 4 over. So it's going to be negative 2. So t equals 1, because negative 2 divided by negative 2 is 1. Are we okay with that? Or do I need to write it more explicitly? Make sense? So I bring the 4 over, so that becomes minus 4. 2 minus 4 is negative 2. Divide by negative 2. That gives me 1. So after 1 minute, the temperature of the coffee is the same as the muffin.